We have an all-new battery pack. And then something we're really proud of is the new carbon-sleeved rotors for the motor. So this is the first time that...
Have you ever stopped to think about what it would actually look like if one company, just one, suddenly leaped so far ahead of the entire electric vehicle industry that every competitor had to pause and genuinely ask themselves, what are we even up against? A few weeks back, when Elon Musk walked onto that stage and revealed Tesla's newest electric motor, most people assumed it was just another product showcase. A few big numbers, some applause, and then life goes on as usual, but that's not what happened. Not even close. Because what Tesla just pulled back the curtain on isn't simply a stronger or more lightweight motor. It's a complete reimagining of what an electric motor is, what it's capable of, and how far the technology can actually go. A carbon fiber sleeve wrapped around the rotor, spinning beyond 20,000 revolutions per minute, launching from 0 to 60 miles per hour in under 2 seconds, Tesla just dragged the entire EV industry onto a completely different playing field, and most of its competitors haven't even felt the ground shift beneath them yet. But here's the part that really gets you thinking. Tesla isn't keeping any of this a secret. They've opened up the patents for the whole world to see. Any automaker anywhere can read them, study them, and try to replicate them. So why doesn't that erase Tesla's edge? Why is it that you can have the full recipe in your hands and still not be able to make the dish? And more importantly, what does all of this mean for the millions of people who are planning to buy an electric car in the next few years? Can other brands actually close the gap? Or are we watching the early chapters of an era where Tesla becomes completely untouchable? Those are the questions we're going to dig into today. And I promise you, the further we go, the more interesting this story gets. Before we dive in, if you're someone who enjoys analysis that goes beyond just reporting headlines and actually explains why things matter and how they change the bigger picture, go ahead and hit subscribe right now. Elon Musk turns a wild dream into a global force. To really understand why Tesla's new motor is sending shockwaves through the industry, we have to rewind. Not just a few years, nearly 2 decades. Back in 2003, when two engineers named Martin Eberhard and Mark Tarpenning founded Tesla Motors in San Carlos, California, the auto industry laughed it off. Electric cars at that point, if you could even call them that, looked like glorified golf carts. No real performance, no serious range, and nobody was lining up to drive one on an actual highway. The idea that an electric vehicle could ever go head-to-head with a gasoline car in terms of power, design, and pure driving excitement was dismissed without a second thought. Not a single major automaker was willing to bet on it. Then Elon Musk showed up. When he invested in Tesla in 2004 and became its largest shareholder, he didn't just bring capital, he brought an entirely different vision of what electric cars could be. Not eco-warrior transport. Not a way to save money on gas. In Musk's mind, an electric car had to be the most beautiful, the most thrilling, the fastest thing you'd ever had the pleasure of sitting in. In 2008, Tesla launched the original Roadster, built on a Lotus chassis, and it was quicker than most gasoline sports cars in its class. It proved one thing, simply but powerfully: an electric motor could deliver real, visceral performance. Not numbers on a spec sheet, but the kind of acceleration that shoves you back into your seat the second you touch the pedal. Then came the Model S in 2012, a luxury sedan with a massive touchscreen, over-the-air updates, and enough grunt to make BMW and Mercedes genuinely uncomfortable. The Model X followed with those dramatic falcon wing doors. Then the more accessible Model 3, which cracked open the mass market. Then the Model Y, and then the Cybertruck, looking like something that rolled off a film set for a sci-fi blockbuster. Every single launch sent shockwaves through the industry. Traditional automakers started scrambling. Ford unveiled the Mustang Mach-E. GM threw billions into its Ultium platform. Volkswagen rolled out the ID series. Hyundai and Kia suddenly became names worth taking seriously in the EV space. A lot of experts around that time started saying Tesla had already hit its ceiling, that once the legacy giants truly committed to electric, Tesla would fade into the background. They were wrong. Because while everyone else was racing to catch up to where Tesla already was, Tesla was quietly laying the groundwork for its next big leap, one that almost nobody in the industry saw coming. Inside the motor. That's rewriting the rules. When Musk stepped out and introduced the new plaid motor with its carbon fiber sleeve, a lot of people's first instinct was, okay, that sounds impressive, but is it actually a game changer? The answer is yes, and the reasons run much deeper than the surface specs. Let's start at the core of every electric vehicle, the rotor. It's the spinning component inside the motor that converts electrical energy into physical motion. In most electric motors today, rotors are built from copper and steel alloys. These materials have served the industry well for decades, but they hit a hard physical wall. As rotational speed climbs, the centrifugal force acting on the rotor increases exponentially. Beyond a certain point, the material starts to deform. Heat builds up, precision drops, and the whole system begins bleeding efficiency at the exact moment you need it performing at its best. Tesla's answer was a solution that sounds almost obvious in theory, but is brutally difficult to pull off in practice: wrapping the rotor in carbon fiber, the same material found in Formula One cars, fighter jets, and aerospace equipment. Carbon fiber has a dramatically better stiffness-to-weight ratio than steel. It's lighter, more rigid, and far more capable of handling the tensile forces generated at extreme speeds. When Tesla wraps this carbon layer around the rotor, it creates what's called a preload, an external compressive pressure that holds the rotor's structure together even as it spins at incredible velocities. The result is a rotor that can push past 20,000 revolutions per minute, a threshold most conventional electric motors never come close to. And that rotational speed is what generates the jaw-dropping power and acceleration you feel when you're behind the wheel. It's how the Model S Plaid gets to 60 miles per hour in under 2 seconds, a number that until recently only existed in million-dollar hypercars from Bugatti or Koenigsegg. Tesla just put it in a family sedan. But raw speed is only one piece of the story. The more significant piece is energy efficiency. A lighter rotor means the motor requires less energy to spin, which means the car can travel further on the same charge, the cooling system doesn't have to work as hard, and battery life gets extended in the process. These benefits all reinforce each other in a loop. A more efficient motor leads to a more durable battery, which extends range and reduces operating costs over time. And then there's thermal stability, something that rarely makes the headlines but matters enormously in the real world. In conventional motors, heat is the enemy. As temperature rises, metal expands unevenly, creating microscopic imbalances that gradually wear down performance. Tesla's carbon sleeve doesn't behave that way. It maintains consistent compressive pressure regardless of temperature fluctuation, keeping the rotor stable across every operating condition. In other words, this isn't just the most powerful motor Tesla has ever built. It's also the most durable, the most stable, and the most efficient, all wrapped up in one design. That small detail might turn out to be the one that changes everything. The secret lies in the execution. Now here's the part that genuinely stopped me when I first read about it. Wrapping carbon fiber around a metal rotor isn't conceptually complicated, but in reality, it's one of the most demanding engineering problems Tesla has ever taken on. Why? Because carbon fiber and metal, particularly the copper and steel inside the rotor, expand and contract at different rates when temperatures change. If you simply wrap the carbon layer around the rotor without extraordinary precision in your calculations, the heat generated during operation will cause the carbon to separate, crack, or create a dangerous imbalance at 20,000 revolutions per minute. You don't need to think too hard about what happens next. To crack this problem, Tesla had to build an entirely new robotic system from the ground up, driven by artificial intelligence, capable of applying the carbon layer with micrometer-level precision. Not millimeters, micrometers, 1/1000th of a millimeter. This system simultaneously controls the tension of the carbon fiber as it's applied, the ambient temperature, the wrapping speed, and the exact angle of each fiber strand. Laser sensors then verify the result, checking for even the most microscopic deviation. Every single rotor goes through individual inspection before it ever sees the inside of a motor. And this is the critical point. Tesla patented this technology and then handed it to the world. Any company can read the design, but the design is not the machine. You don't have the AI system trained over thousands of test runs that knows precisely how much tension is right. You don't have the quality verification process that's been refined over years of real production. And even if somehow you had all of that, you'd still need to integrate the whole system into a production line capable of turning out tens of thousands of units every month. This is Tesla's masterstroke. Opening the patents isn't a gesture of generosity, it's a demonstration of the gap. They're essentially telling the industry, we've gone so far ahead that even if you know every secret we have, you still can't keep up. The challenges Tesla would rather you forgot. Of course, nothing is flawless, and if we only heap praise on Tesla without honestly looking at the real risks, then this isn't analysis. It's a fan video. So let's be straight about the challenges Tesla is still navigating. First, production cost. Carbon fiber sleeve technology manufactured at micrometer precision isn't cheap. Every rotor demands significant machine time, rigorous quality inspection, and expensive raw materials. While Tesla is scaling up production quickly, the cost per plaid motor is still considerably higher than a conventional one. The real question is whether Tesla can bring this technology down market into the Model 3 or Model Y, or whether it'll remain an exclusive feature of their premium lineup for the foreseeable future. Second, financial pressure. In 2024, Tesla went through major layoffs and faced mounting questions about shrinking profit margins as the price war with Chinese competitors turned brutal. BYD, SAICNIO. These aren't scrappy startups anymore. They're manufacturing millions of vehicles at significantly lower costs and aggressively pushing into international markets. In a price war, superior technology doesn't automatically win. Third, the risk of being too tied to one person. Elon Musk is both a marketing force of nature and the strategic brain behind many of Tesla's biggest innovations. But the brand's deep entanglement with him is also a vulnerability. The controversy that follows him across social media, the divisive statements, the promises that haven't always landed on schedule, all of it chips away at consumer trust, particularly among older, more experienced buyers who weigh credibility heavily. Fourth, charging infrastructure. Tesla's supercharger network remains one of its strongest assets in the US, but as Tesla opens those chargers to other brands, that exclusivity starts to erode, and range anxiety continues to be a real psychological barrier for buyers in regions where charging options are sparse. Fifth, the self-driving promise. Tesla has been talking about full autonomous driving for years. The technology has made genuine progress, but it still hasn't arrived at the level Musk once described. That gap between promise and delivery does real damage to credibility over time. None of these challenges undo what Tesla has accomplished with the Plaid motor, but they're a reminder that in the commercial world, the best technology and the best business outcome aren't always the same thing. The rivals who refuse to quit. When Tesla revealed the Plaid motor with its carbon sleeve, competitors responded in different ways. Some went quiet, some downplayed its significance, and some quietly turned up the heat in their own labs. Let's walk through each of them. Lucid Motors is the most technically formidable rival in pure engineering terms. The Lucid Air Grand Touring Performance offers more than 500 miles of range, a number the Model S still hasn't matched, and their drivetrain reflects a genuinely sophisticated level of engineering. The problem is sales. Lucid produces and sells a relatively small number of cars each year, operating almost entirely in the ultra-luxury niche. Without the revenue that comes from volume, they simply don't have the resources to develop next-generation motors at the scale needed to truly challenge Tesla. Rivian is carving out its own lane with electric trucks and SUVs built for adventure. Strong design, a loyal following, and Amazon's backing give them a solid foundation. But on pure motor technology, they're still working with a more conventional architecture, and the gap with Tesla is widening. Among traditional automakers, the F-150 Lightning had decent sales and proved that Americans will buy electric trucks. But Ford still depends heavily on outside suppliers for batteries and motors, and it's been forced to slash EV production targets multiple times as costs spiraled. With a business model that still straddles gasoline and electric, Ford can't go all in on radical motor technology the way Tesla can. GM has committed nearly $35 billion to electrification, but its Ultium platform, once positioned as the cornerstone of its EV future, has been hit by delays and real-world deployment headaches. The Cadillac Lyriq and Chevrolet Equinox EV are solid vehicles, but neither has produced the kind of technological moment that Tesla just delivered. And then there's BYD, the name Tesla probably watches most closely. This Chinese company has overtaken Tesla in total global EV sales and operates one of the most vertically integrated supply chains in the industry, producing its own batteries, chips, and key components in-house. Its production costs are significantly lower, and it's pushing hard into Europe, Latin America, and Southeast Asia. But BYD has one meaningful weakness. Its brand and software ecosystem haven't broken through in the United States. American consumers, particularly those over 45, still lean toward brands they recognize and trust. And until BYD can actually enter the U.S. market at real scale, something currently blocked by tariffs and trade policy, Tesla holds its home turf. The bottom line is this: no single rival is challenging Tesla on every front simultaneously. Lucid has the engineering but not the scale. BYD has the scale but not the American brand equity. Ford and GM have the brand recognition but lack both. And Tesla now has everything, plus a motor nobody else can currently replicate. When an electric motor becomes bigger than cars. Here's where the story gets truly large, larger than any single vehicle or any single competitive race. During the Plaid motor presentation, Musk said something that most people skipped right past because they were locked onto the performance numbers. He suggested that this motor, with its exceptional power-to-weight ratio, thermal stability, and capacity to sustain high-speed operation over extended periods, has potential applications that go well beyond automobiles. Consider electric aviation. One of the biggest obstacles for electric aircraft has always been the propulsion system. The motor needs to be light enough not to compromise the aircraft's weight budget, but powerful and reliable enough to operate safely under demanding conditions. Countless startups are chasing electric vertical takeoff and landing aircraft, and they keep running into the same wall. Current motors are either too heavy or too inefficient across the required speed ranges. Tesla's Plaid motor with its carbon sleeve could be the missing piece. Light, powerful, thermally stable, capable of running at high RPM for sustained periods without performance degradation. Those are precisely the characteristics the electric aviation world is searching for. Tesla hasn't officially announced any licensing agreements with aviation companies, but the indirect signals are becoming harder to ignore. And if that door opens, Tesla stops being just a car company. It becomes a hardware supplier for a full-scale energy revolution. Think about industrial infrastructure, wind turbines, large-scale pumps, grid-scale storage systems. All of them rely on high-efficiency electric motors that can handle harsh, demanding conditions. If Tesla can bring the cost of Plaid motors down through economies of scale, it could position itself as the go-to electric motor supplier for the entire clean economy, from passenger vehicles to aircraft to the power grid itself. This isn't speculation for the sake of it. It's the logical next move for a company that already runs gigafactories on 3 continents, supplies megapack batteries to national power grids, and has Powerwall solar systems running in millions of homes. Tesla isn't just competing in the auto industry anymore. It's building the energy and mobility infrastructure for the 21st century. While its rivals are trying to build a better electric car, Tesla is trying to architect a world that doesn't need fossil fuels. Those are two completely different games. And the long-promised Roadster 2.0, which Tesla has teased and delayed more times than anyone wants to count, could become the ultimate showcase of everything the Plaid motor can do. If it actually arrives with the performance figures Tesla has dangled in front of us, under a second from 0 to 60 miles per hour, more than 600 miles of range, and full deployment of the latest motor technology, it won't just be a fast car. It will be the most powerful technological statement any automaker has ever made. The game isn't over, but Tesla is rewriting the rules. We've covered a lot of ground, from the original Roadster in 2008 all the way to a rotor wrapped in carbon fiber with micrometer-level precision. But before we wrap up, I want to step back and be straight with you about the most important takeaway from everything we've discussed. Tesla's plaid motor technology is real. The performance numbers are real. The engineering gap between Tesla and its closest rivals, at least right now, is real. But the history of technology has a habit of humbling even the most dominant players. Betamax was technically superior to VHS. VHS won. BlackBerry's physical keyboard was better than any touchscreen at the time. The iPhone rewrote the rules anyway. Nokia ruled the mobile world for years, then nearly disappeared in the blink of an eye. The EV market is still forming. Consumers are getting sharper and more selective. Government incentives can shift with a change in administration. Battery costs are dropping fast, which can compress anyone's cost advantage. And in an increasingly volatile geopolitical environment, supply chain decisions and trade policy can redraw the map in ways nobody can fully predict. So yes, Tesla has just done something extraordinary with this new plaid motor. But is this truly the moment that ends the EV race as we know it? Are rivals really incapable of closing the gap, or are some of them quietly developing breakthroughs that haven't surfaced yet? Honestly, I don't know. And if someone tells you they have a definitive answer, you should probably raise an eyebrow. What I do know is this. What's unfolding in the electric vehicle world right now, the fierce competition, the technical leaps, the price wars, the infrastructure arms race, is actively shaping the future of how the entire planet moves. And what happens over the next 3 to 5 years could define this industry for generations. What do you think? Has Tesla genuinely ended the competition with this new motor? Or can rivals, from Lucid to BYD, to names we haven't even heard yet, still pull off a surprise? Drop your thoughts in the comments below, especially if you own a Tesla or you're seriously considering going electric. Real opinions from real people are always the most valuable ones here. If this video gave you a new perspective on where the EV revolution is actually headed, hit like. It helps get this content in front of more people. And if you want to keep up with deep dives like this, not just ON Tesla, but on the full picture of technology and energy reshaping our world, make sure you're subscribed to the channel.